Okay, guys, just trying to get this lined up for you. This is the college algebra review for Ms Jackman's class. Now you're going to have to bear with me. This is pulled up on Math Excel. You may or may not have the exact same questions, so I'm not sure. Also, I'm worried about you being able to read this off of the board. So just bear with me. Maybe you can stop, zoom in or something if you have a question. It says in a typical diabetic, the level of insulin might be given by the following function. Now they're giving you a piecewise function. You're going to use the first equation if t is between 0 and 3, the second equation if t is between 3 and 8, and so on. It says here f of t is the blood sugar level in appropriate units at time t, measured in hours from the time of the injection. Suppose a patient takes insulin at 8 a.m., find the blood sugar levels at 9 and at 7. Now, 8 a.m. is your start time, that's 0. First question is at 9 a.m. the blood sugar level is blank units. So 9 a.m. is 1 hour past 8 a.m. So you're going to let t equal 1. So that's going to fall between 0 and 3. So you'd plug 1 in here, so 50 times 1 plus 120, that's going to be 50 plus 120. That would be 170 units of blood. Okay, I hope you can see that there. All right, second question is at 7 p.m. This is where you got to be careful. We're starting at 8 o'clock in the morning. So if you go from 8 a.m. to 12 p.m., excuse me, that's going to be 4 hours. And then from 12 to 7 is going to be another 7 hours. So that's a total of 11 hours. So you're going to let t equal 11 hours. So which of these domains does that fall into? It falls in the 10 to 24 range, 11 hours. So that function is just 130. There's no t to plug into, so the answer is 130 units. And that is all of question number 1, I believe. I'm really hoping these match up to everybody's Math Excel, but I do not know for sure. Okay, number 2 says find the inverse of the following function. Now, inverse means opposite. So anytime you're asked to find the inverse and they give you an equation, you're going to switch x and y, and then solve for y. So when you hear inverse, think switch x and y, solve for y. All right? So we have, this is your y, because f of x stands for y. So we have y equals negative x minus 4. Where there used to be a y, we're going to put x. Where there used to be x, we're going to put a y. And now we're going to solve for y. So we're going to add 4. So we have x plus 4 equals negative y. And then we're going to divide everything by a negative to make this a positive y. So that becomes negative x minus 4 equals y. Now that's not just any y, that's the inverse. So f to the negative 1 stands for inverse. So you would type in negative x minus 4. That is the inverse of y. Negative x minus 4. All right, that's how we copy that. Question number 3. All right, these word problems are going to be a little trying on here with the graphs and whatnot. In a certain state, the percentage of working mothers Y can be modeled by the equation y equals 0.0102x plus 0.642, where x is the number of years since 1990. Use the accompanying graph to estimate the year in which 70% of mothers were in the workforce. Now, the percentage of workers is Y. So we're trying to see when it's 70%, what year was that? So we're going to have to make the graph larger. And try to make the graph larger. Ooh, that does not help. Okay, that's better. Now you probably can't see this on the computer, okay? But 70, there's actually some more grids here, is right there. And that corresponds to an X or a T of 6. So when T is 6, it was 70%. Now be careful, it says use the accompanying graph to estimate the year. the year is not 6. This is the years since 1990. So you're gonna do 90 plus 6. So that would be 1996 is when 70% of mothers were in the workforce. Part B, is the percentage of mothers in the labor force increasing or decreasing? Well, you read left to right, obviously it's increasing. The percentage is increasing. And then it says use the equation to find the year, so we're looking for X, in which 95% of mothers will be in the labor force. Okay, so we're not gonna use the graph sign, we're gonna actually use the equation. So in the equation, let me see if I can make that small again. Yeah. Okay, so in the equation, we're gonna let Y be 95, and we're gonna solve for X. Now we're gonna need to use a calculator that, I'm gonna rewrite the problem here and then make the screen go blank for a second. So the equation is Y equals 0.0102X plus 0.642, all right? And we're gonna let Y equal 95. So let me put the screen. Okay, hopefully you can see that. That is right in the glare, I apologize. Let me rewrite this. And then what year did it ask for, I believe it? Or it asked for a percent of, come on, Rita. It asked for 95%. So we're gonna go, and the percent is your Y. So we're gonna plug in 95 here, and we're gonna solve for X. So you're gonna minus 0.642 on both sides. We get the calculator out here, we have 95 minus 0.642. So on the left, we have 94.358 equals 0.0102X. You're gonna divide by that number and divide by that number to solve for X. And so you take that divided by 0.0102. I got 9250.78, which makes me think something's up. Let's go back and read the question. This makes me think maybe we shouldn't have used 95, we actually should have used the percent, 0.95. So I'm gonna recalculate using 0.95. On the graph, it just says the number. So let's try this again. I apologize. So we're gonna take 0.95. So it's also good to know if your answer makes sense. I'm gonna say 0.95 and subtract 0.642. You get 0.308. And then you're gonna divide by 0.0102. So divided by 0.0102. That makes a little bit more sense there. So we got about 30.196. We'll see what they wanted us to round to in just a minute. So we go back to the question. We got X equals 30. Now remember, X is the years that have passed since 1990. It wants to know in what year. So if we looked at the graph, 95 is right here. That does match up with a little bit more than 30, so our answer makes sense. But it's not the year 30, it's 30 years past 1990. So you would do 1990 plus the 30.2. And it doesn't say what to round to. Let me see if I scroll down there. Probably the nearest year. Good thing. Yeah, we're just gonna do 1990 plus 30. So about 2020. 30 years after 1990. Okay. which you sort of could have used the graph and gotten it done as well. Let's move to number 4. Okay, word problem. I don't know if you can read it. Not sure if you guys have the same question on your math Excel. Sometimes they're all different, depending on how the teacher sets up the class. So it says the motor vehicle ownership in developed countries can be modeled by the function m of t equals, and you have 2 different linear equations that are pieced together. That's why it's called a piecewise function. This one you're going to use from t equals 0 to 20, this one from 20 to 40. It says where t is the number of years since 1970, and m of t is the number of motor vehicles in millions in the year 1970 plus t. See the accompanying figure. So they give you a graph. How many vehicles were there in developed countries in 1986? How many were there in 2005? So you have 2 questions. I believe that's it. Let me see if I can scroll more. Yeah, and then what was the average rate of change of the motor vehicle ownership from 84 to 94? This is one question, but it's really packed. So in 1986, there were blank million vehicles. Well, 1986 is how many years past 1970? So you would do 86 minus 70, that's 16 years have passed. So you're looking for t equals 16. Okay, we're looking. The first question, 1986 is t equals 16. So you're going to plug that into the first equation because 16 is between 0 and 20. So you would use m of t, which is really m of 16, is going to be 16.5 times 16, because that's your t, plus 300. I'm getting this from the first equation that you're piecing together. Type that in the calculator. Let's see what you get. We have 16.5 times 16, okay, plus 300. I got 564. 564. So in 1986, there were 564 million vehicles in developed countries. All right, what about in 2005? On 2005, you got to calculate how many years that is past 1970. So 2005 minus 1970, that's 35 years. So in this half of the problem, or the part B, you're going to let t be 35. That falls in your second equations domain because 35 is between 0 and 40. So you're going to use the equation 10t, so the m of 35. We're going to do 10 times t. T this time is going to be 35 plus 430. 10 times 35 plus 430. We get 780. So the second half of this question, in 2005, there were 780 million vehicles in developed countries. Okay. Now, this third part's a little bit trickier. It says the average rate of change in motor vehicle ownership from 1984 to 1994 is blank million per year. Type an integer or a decimal. Okay, we're going to have to do a little work here. So we need to know the amount of vehicles in both of these years, and then we're going to find average rate of change means slope. So we would do y minus y over x minus x. So let's do the let's do 1984 first. 1984 from 1970, that's 14 years have passed. You would plug 14 into the first equation because that's where it falls in the domain. So the m of 14 is going to be 16.5 times 14 plus 300. 16.5 times 14 plus 300. We get 531, okay? Now that's an ordered pair. When t is 14, there's 531 million vehicles. Don't judge my 3. Okay. In 1994, how many years have passed since 1970? That would have been 24 years. You want to find m of 24. So which equation do you use? You use the second equation because 24 is between 20 and 40. All right, so we have 10 times 24 plus 430. use your calculator. You got 240 plus 430. That should be like 670. That's another ordered pair. 24, 670. Average rate of change means slope. Average rate of change means slope. So you're gonna do the y minus the y over the x minus the x. That's the slope formula. In case you forgot the slope formula, y2 minus y1 over x2 minus x1. So 670 over minus 531 divided by 24 minus 14. Well, the denominator is easy. That's 10. 670 minus 531. I'm going to use calculator. We can't take any chances here. We have 139 divided by 10, which is 13.9. So I would type in 13.9 million per year. So it's increasing. The average rate of change of motor vehicle ownership, it's increasing by 13.9 million cars or ownership per year. Okay. We don't love word problems. They're really not bad, but that problem was pretty packed. Question number 5. Okay. Determine whether the relation is a function. Now, your teacher is giving you a set of ordered pairs. Here's what you got to remember about a function. You could graph it and do a vertical line test, okay? Or you could remember that each x can have one and only one y. Remember, x's are girls, y's are guys. Each x, each girl, can have only one guy. So we really just need to inspect the x's. We have a 2, an 18, a 41. I got another 2. So your girl 2, your girl is your x's. Your girl 2 is seeing 2 different y's. That is not a function. Now remember, if a y is seeing 2 different girls, 2 different x's, that's okay. That's still functional. It's not one-to-one, but it's still functional. But an x, a girl, can only see one guy, one y. So that would be a no. Okay. Use the vertical line test on the graph given to the right to determine whether y is a function of x. So you can take a vertical line like your pencil, you drag it left to right. If your graph touches in more than one spot, like the circle does, it fails the vertical line test. This is not a function. It touches your vertical line in more than one spot at a given time. See, what's happening is, like for example, when you go to x equals 1, there's 2 different y values. So your girl x is seeing 2 different y's. That is not a function. Not a function. All right. Use transformations to graph the following function and state the domain and range. Okay. We have a quadratic because it's x plus 2 squared minus 3. Now, transformations. Plus 2 is with x. You think you would go in the x direction right 2, but if it's with x, you're going to go left 2. And then minus 3 means down 3. Now, you have a graphing calculator as well. Okay? So the vertex here is going left 2, down 3. Okay? And then you're going to need to know another point on the graph. So if you want to graph this on your calculator and use a table to find the second point, you can. Or you can also plug in another number. For example, if you plug in -2, -2 plus 0 is, -2 plus 2 is 0. That's 0, -3. So that is -2, -3. That is your vertex. You can pick another number like 1. 0, you can pick any number for each one. Let's just pick 0. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So I know the vertex is at -2, -3. Okay, because left 2, down 3. And I know when I plugged in 0 for x, I got 1. Because that's 2 squared. 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So now let's talk about how to do this. See if we can make this bigger. Okay. That is so small I can't even see it. Oh, okay, I got you. So we're going to choose parabola because it's quadratic. I'm going to go to -2, -3, and then I'm going to go to 0, 1. And that's how you do it. So you click on the graph. We don't have a line. We don't have absolute value. We have a parabola. So I choose the up parabola. I click on the vertex, which was -2, -3, Then a second point I picked was 0, 1. You could have picked other points. And then you're done, you would hit save. Okay? Now, there's another question that goes with this. What is the domain? What is the range? Okay? So let's talk about domain and range. Domain is X. X goes left to right. Does the parabola ever quit going left? No. Does it ever? I know it's going up, but it's going left and it's going right. So your domain would be from negative infinity to infinity. It says interval notation. So you do parentheses, negative infinity, comma, to infinity. That domain is range. I'm sorry, domain is X. Now let's go to range. Range is Y. Y goes up and down. Range, Y goes up and down. The graph does not go down forever. The graph only goes down to -3. So your Y values start at -3 and go up forever. So it starts at -3. And you're going to put a bracket because it touches at -3 and then it goes up forever to infinity. Parentheses always on infinity. Remember, you always work on the domain X, you always work left to right, smallest to largest, and on the range, you always work bottom to top, smallest to largest, -3 to infinity. Okay, so we graphed it, domain and range, pretty easy, says the math teacher, right? Okay, I'm not trying to complete all the parts of the question, I'm good. Okay, so we have a table. And another word problem says the accompanying table shows the depth below sea level, D, and the pressure, A. The equation A of D equals blah, 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 expresses A as a function of D. Find the pressure for a depth of 120 feet. Okay, so pressure is your A when there's a depth, D, of 120. So you're going to use this equation and plug in 120. So the equation, A of D, depth is 120, so A of 120 is, I believe that's a 0.03 times D, 120, plus 1. You can use your calculator, type that in. You get 0.03 times 120 plus 1. You get 4.6. So the pressure will be 4.6 ATMs at a depth of 120 feet. Now, on the part B, they want you to work backwards. It says find the depth, so find D when the pressure is 5.8. So on that one, you're going to work backwards. Okay? In the equation, we don't know D. Okay? And we do know A. We do know the pressure, 5.8. Tell you what, it's really hard to say the decimals on this. So 5.8 goes in place of the A. We're solving for D because we're looking for depth. This is a two-step algebra 1 equation. You're going to -1, -1. And then you're going to divide by 0.03 on the right, divide by 0.03 on the left. 4.8 divided by 0.03. And I got 160 feet for the depth, and you would type that in there. Okay? And they're just looking for you to fill in the table. Pretty simple stuff. Question 9. Write the function whose graph is the graph of y equals x cubed, but is translated 8 units up. Now, so we got the cubic function, which looks like this. All right, up and down is y, so we're not going to go inside with x. So we're going to, up is going to be on the y-axis. And since you're translating, it's going to be either add or subtract. And if you're going up, you're going to do +8. Whatever you do to y, you do to y. If it was in parentheses with x, you would do the opposite. Yay, more word problems and graphs. Okay, suppose the record times in the 2,000-meter race at a certain venue are a function of the number of rowers as shown in the figure. So we have a graph on the right. If R is the number of rowers, so like I like to underline stuff like that. I know it's on a computer, but R is the number of rowers, T is the time in minutes. Then the formula T equals, so they're giving you an equation, models the relationship, okay? Is this function invertible? Find the inverse. If the time for a 2,000-meter race was 6.59 minutes, then how many rowers were probably in the boat? Okay, first of all, it is invertible. Invertible means does it have an inverse? Now, we've done the vertical line test. A vertical line test tells you if a graph is a function, tells you if a relation is a function. But if you do a horizontal line test, it tells you if something has an inverse. And this passes the horizontal line test. If I had a parabola, that would fail the horizontal line test, okay? So there would have to be a restriction in order to find the inverse. So, select the correct choice. The function is invertible. It is. So what you gotta do is you gotta switch R and T and then solve for R. Because right now it's solved for T. So where there is a T, we're gonna put R. Where there was an R, we're gonna put a T. I'm gonna use a capital T. And then we're gonna solve for R. Well, guess what? It's already solved. Normally you switch X and Y and solve for Y. It's already solved. Sorry, I was reading. That seems too easy. All right, so let's read. Let's scroll this part down, sorry. The time for a 2,000 meter race was 6.59 minutes. Then how many rowers were probably in the boat? Select the correct choice below, fill in the blank. Okay, so now, I'm just gonna use the equation given, okay? 6.59 is gonna go in for T. And then you're gonna solve for R because I want to know how many rowers. So you're gonna minus the 8.49 minus the 8.49. Let me grab a calculator. So I have 6.59 minus 8.49. That gives me negative 1.9. And then I'm gonna divide by negative 0.3, divide by negative 0.38. So I get 5 rowers. So if it took 6.59 minutes, there should be about 5 rowers in the boat. Okay, good. So question 11 says, it gives you f of x, it gives you g of x. It says find and simplify the expression. The expression is f plus g of 4. Now, some people like to add f of x and g of x together with x's and then plug in 4. I personally find it's easier to plug in 4 into f, 4 into g, you get a number, and then add the two numbers together because it wants you to add f and g. So that's what I'm gonna do. I'm gonna take the f of x equation, and where there's an x, I'm gonna plug in 4. So it's x plus 1, so I'm gonna do 4 plus 1, so the f of 4 is really just 5. Okay, now I'm gonna do the g equation. So the g of x, I'm gonna do the g of 4. So we have 4 squared, because it used to be x squared, minus x is 4 now. Okay, you can use a calculator for that if you need to. That's 16 minus 4, which is 12. This is f of 4, this is g of 4. We want to add the two numbers together. So 5 plus 12, 17. Question 12. Okay, this looks a little overwhelming. This is not bad at all, okay? So don't be scared. Normally, guys, in math, the more words, the easier the math. And some of you that are English people probably like these better anyway. I'm not an English person, so I'd rather have more math. Okay, we see everything there. That's good. It says determine the correct graph that best depicts the following scenario. Profits for a company soared during the 50s. So soar would mean goes up. Then they went flat after they crashed in the 60s. So flat means they crashed, they went down. So they went up, they went down. The company saw a period of moderate decline in the 70s. So we're looking, first of all, we're looking, it's gonna go up. That goes up, that goes down first, that goes down, that goes up. Okay? So this is going up, it says soared during the 50s and then went flat after they crashed. So they crashed down here and then went flat and then declined in the 70s. Looks like A is the best choice. Now, let's talk about D. D increased, but then stayed high, was like at a constant high level and then decreased. This says it crashed, it went flat after they crashed. So jump down here, crashed, and then went flat for a while, and then declined again. So A is the best choice. See, English people, math is not so bad now, right? Okay. Number 13, suppose the function v equals blah expresses the landing speed v in feet per second as a function of the gross weight in pounds of a certain aircraft. Find the inverse function. Use the inverse function to find the gross weight for one of these aircrafts for which the proper landing speed is 111 feet per second. Okay, so how do you find the inverse? You switch the variables and solve for the variable you want. So the inverse, I'm gonna pause right here. Can I pause this? I don't even know. I don't like their wording here. I think they want you to just solve for W. I don't think they actually want you to find the inverse. Because if I just switch W and V, then it's there. I think they want you to solve for W, so we would square both sides. So that gets square the left, square the right, squares and square roots cancel. So V squared equals the stuff, and then I would divide by that by that. 1.414. So W is equal to V squared divided by 1.414. That's what W is equal to. Now, it says the gross weight of the aircraft is blank pounds. Now, we gotta go back to the prompt here. It says use the inverse function to find the gross weight, so we're looking for W, for which the proper landing speed is. Now, remember landing speed is the V, is 111 feet. So you put 111 here, square it, divide by 1.414. So weight equals 111 squared divided by 1.414. Not really fond of the wording on this problem. So we have 87. Let's just take a round to the nearest integer. It's 8713.5, so that's going to be 8714. 0.5 rounds it up to the next pound. All right, 8,714 pounds, approximately. Okay, total profit is defined as total revenue, R of X, minus total cost. So revenue is the money you're bringing in, cost is what you're putting out, you subtract the two, that gives you your profit. And it's given by the function P of X equals R of X minus C of X. Suppose R of X equals blah, C of X equals blah, what is P of X? This is really just an Algebra 1, Algebra 2 question. They want you to find P of X. They tell you R of X minus C of X, they give you the equation for it, and then they give you R and C. So it's stuff minus stuff, and you're going to combine like terms. So R of X was 60X, I'm getting this from right here, 60X minus 0.3X squared, and then C of X was 2X plus 1 plus 13, excuse me. Now be careful on this. You are minusing both of the terms in the binomial, you're distributing it. So we have 60x minus 2x, those are like terms. 60 minus 2 is going to be 58x. Nobody is like x squared, so you bring down the negative 0.3 x squared. Now be careful, this is not 13, it's minus 13. That's where most people mess up. So your answer is 58x minus 0.3, x squared minus 13. You can put it in standard form with the x squared first, the x second, and the minus 13 last if you're OCD. I'm too lazy to rewrite it, so I'm leaving it. All right, 15. The surfboard shaper has to limit the cost of development and production to $344 per surfboard. He has already spent $99,876 on equipment for the boards. The development and production costs are $141 per board. The cost per board is blah. Determine the number of boards that must be sold to limit the financial cost per board to $344. How many boards must be sold to limit the cost? Okay, this is a little wordy. Okay. We're trying to limit the final cost of the board to $344. Okay, so let's go back. He's already spent this much on equipment. The development and production costs are $141 per board. So these are costs. The cost per board is, okay, they gave you the equation. All this stuff up here, they actually give it to you. So your cost is equals $141 per board. That's given to you here. That's in development and production. Plus, we already owe this $99,876 over X, because this is the total cost, okay, cost per board plus the other costs we've had. When you divide by number of boards, that's your cost per board. It says we want to limit the cost per board to $344. So we want this to be no more than $344. Okay, we need to solve for X because it says how many boards must be sold to limit the cost of that. All right, so we're going to multiply both sides by X first of all to get the fraction out of there. So multiply by X, multiply by X. All right, over here the X on top, bottom cancel. We have 141X plus 99,876. We're going to subtract 141X and subtract 141X to get letters left, numbers right. So we have 344 minus 141. So it gives us 203X. And we're going to divide by 203, divide by 203. So 99,876 divided by 203. That's 492. That's how many boards we have to sell in order to limit the cost per board. So 492. So the key on this problem is the first two sentences, maybe three sentences, confusing, but then they give you, this right here is what you want to key in on. Cost per board is, so cost, C, is, and they give you an equation. They tell you what the cost needs to be, 344, you plug it in, you solve for X, the number of boards. Okay, not too bad. They give you f of X and g of X, and they want you to find f dot g of X. Not open circle, but closed dot. That means multiply. So we're going to take f times g of -5. This is a number. There's no sense taking the binomial times the binomial and foiling with x's because we have a number. So find the f of -5, find the g of -5, and then multiply the two answers together is the easiest way to do this problem. So I'm going to find the f of -5. Everywhere there's an x, I'm going to put parentheses, and instead of x, I'm going to plug in -5. Parentheses are really important when using the calculator if you're going to use a calculator. -5 squared is 25, 25 minus 1 is 24. Now let's find the g of -5. You're going to use your g equation. 14 minus x, well, we don't have an x, we have 14 minus parentheses, and in parentheses, we're going to plug in -5. Minus a negative means plus a positive, 14 plus 5 is 19. So we're going to take the f of -5 and the g of -5, 24, multiply it to 19. We'll get our answer. And that is 456. So 456 is the answer to number 16. All right, determine the domain and range of the relation. Now, You're given an equation. You could just graph this. Guys, if you graph the square root of x minus 8 on a calculator, you should know what it's going to look like. It looks like the square root of x, okay? Minus 8 is with x. You think it would go left x, but it goes, sorry, left 8, but it goes right 8. So the graph starts right here and is this. You can graph it on the calculator if you don't believe. Okay? So domain. Domain is x. Remember, d comes before r, x comes before y. So x goes left, x goes right. Well, how far left does this graph go? It only goes as far left as 8. So the graph actually starts at 8, so you're going to put a bracket there. It goes right forever, so it goes from 8 to infinity. What about the range, the y values? That's up and down. Y goes up and down. Well, the lowest it goes, the lowest point on the graph is 0, touches at 0, so we use a bracket, and it's going up forever, so to infinity. All right, domain and range, pretty simple. All right, what's the next one saying? Determine algebraically whether the function is even, odd, or neither. Okay, we're going to use quick review. If you have a polynomial and every single term is even, then it's an even function. If every single term is odd, then it's an odd function. If there's a mixture of even odds, then it's an even. Well, we only have one term here, it's a monomial. The degree is 3, which is odd, so we have an odd function. Odd functions are symmetric around the origin, so that's that. If it was an even function, let me give you an example of an even. Y equals x to the 4th plus 3x squared plus 7. How is that even? You have 3 terms. Even degree, because it's to the 4th, even degree because it's to the 2nd. This is degree 0, which is also even. They're all even. The whole function is even. In an even function, it's symmetrical across the y-axis. So, odd function, symmetrical across the origin, O, odd, origin. Even function, symmetrical across the y-axis. Now, one last example to make sure you get through this. What if you're given something that has a mixture of degrees? Like we have x to the 3rd plus 6x squared. Degree is odd 3, degree is even 2. You have a mixture, therefore the function is neither even or odd, and it would have no symmetry across the y-axis and no symmetry across the origin. You can also graph on your calculator if you need an idea. Will help if you have brain freeze. Okay, 2 more questions, let's roll. Now, number 19 is an f of x, g of x question, but it's a function inside of a function. It's f of g of negative 7. Okay, so you have a function inside of a function, f of g of negative 7. When you have composition of functions, you got to work your way inside out. Remember, it's what's on the inside that counts. So you need to find what the g of negative 7 is before you go on. You got to find this first. So let's use the g equation to find g of negative 7. So g of negative 7 is x squared, so something squared, plus 3. That's the rule for g of x. X squared plus 3, something squared plus 3. Instead of x, we're going to plug in negative 7. You can use the calculator. Parentheses are important. Negative 7 squared is positive 49. 49 plus 3, 52. That is the g of negative 7. We're going to come back and plug that in right there. G of negative 7 equals 52. Now we're finding the f of 52. Well, that's the rule for f of something. All right, it's negative 5 times something. Negative 5 times something minus 1, and instead of x, you're going to plug in 52. You can type it on the calculator, negative 5 times 52 minus 1. Use parentheses. Negative 5 times 52 minus 1. We get negative 261. That's called composition of functions. You have a function inside of a function. Okay, last question. Determine whether the function is invertible. If it is, find the inverse, and then select the correct choice. Now, for invertible, we're not doing is it a function. Okay, if it's a function, you're looking for every x to have one y. If you're looking for an inverse, you're looking for every y to have one x, which would be the horizontal line test. So look at your y's. None of them repeat, so it is invertible. An inverse just means switch x and y. So you would list the ordered pairs in the side of the set, and you're just gonna switch the ordered pairs. So instead of 3, -5, you have -5, 3. Instead of -4, 6, 6, -4. Instead of -2, 1, 1, -2. And instead of -1, 4, 4, -1. And then you're typing them in the set, because that's the entire set of ordered pairs. So yes, it is invertible, and that is the inverse. Switch x and y. Okay, I think that's it. Guys, I really don't know if you're gonna have the same questions on your Math Excel. I hope they are. They should be similar, if not the same numbers. If you have any questions, my cell number is 270-889-7710. You can also contact me through school email, Facebook, Instagram, Twitter, whatever. Text message is the best way to get me though. All right, y'all have a good night. And that is all.